And here we are for Piecewise 5. And doing Piecewise 5, we're going to start out with a problem similar to problem 1 on your worksheet. And you're going to see that we have two parabolas. The one on the left is opening down with an open circle at its vertex, because I'm always giving you the vertex in these. When you get into pre-calc, we'll do somewhere I move it off the vertex, but right now we're just stay on the vertex while you're learning piecewise. And the right side, notice it opens up, it's going to the right, so right and up. They have different vertices because those are their endpoints right now, and so remember we call this a jump. When I go to the left, I could have done the number 0, -1, -2, but for whatever reason, my brain was just thinking that order. And so -2, and I'm opening up, so these are supposed to be positives. So I'm going to go 2 left, up 4, 1 left, up 1, and just stay at the vertex. And so let's go ahead and do that. And so the vertex is actually 0, 0. So I'm going to put in try to get in my 0 there. So there's my 0. And now I want to go 1 left, 1 up, 1 left, 1 up. And then I want to go 2 left and 4 up. 1, 2, 3, 4. It's easier for me to count up the axes. So there I have my points, and I have my half of my parabola. Now, the vertex for the other one is 0, 1, and it's closed. And it's a parabola that opens to the right and up. So right 1, right 2, up 1, up 4 from the vertex. So I'm going to go right 1, up 1, then back to the vertex, right 2, up 4. And now, that other one I did do it wrong. Jeez Louise, folks. Just like in class, it does have a negative x. So these were supposed to be negative signs. Don't you love it when your teacher does the same thing she does in class? And so I want to go left 1, down 1, then left 2, 1, 1, 1, 2, 3, 4, down 4. And so my parabola sections look like this. And so I'm opening left and down, pretend like it went through that point, and I'm going right and up. And we can see it's a jump. So yeah, just use your humor. Do what you're used to with me in class. Okay. Oh no, I lost my marker. Okay, next one. Looks like problem 2 on your worksheet. And so here we are. And so what I now have is the left side parabola opens up, and the right side parabola is opening down, and I have a point in between. Now notice the two parabolic sections, the parabolic ray left and the parabolic ray right, each go to the same point, so they're going to connect, but it's going to be an open circle. So the function value 3 is not shared with that, and so this is what we learned the other day was called a hole. So for the first one, I'm going to go to the left side because I told you it's a parabolic ray left. So I need -2, -1, and 0. And you could go 0, -1, -2. You know, I don't care. And so the vertex point is 0, -2. So here's 0, -2. And now I want to go 1 left and up 1. And then I want to go 2 left, and I want to go up 2. And then I draw my parabola. For the other section, let's just, since I'm on parabolas, do it. This one is going right, as the directions told us, go right. So 0, 1, 2, and the standard up 1, up 2, we have the same vertex. And so I'm going to go, oh no, it said to go down. Didn't see that. Put in my little negatives here. So I'm heading down. I fixed that up. So I'm going to go right 1, down 1, back up to the vertex, right 2, down 4. And when I look at this picture, it's called a hole, and it's called a hole because there's nothing there. The ordered pair is at 0, 3. And notice, if I were allowed, which I'm not, so this is a teaching moment, don't put this on your graph, but if I could fill this in, see that nice black point? If that were legally filled in, now it looks continuous. That's why you know it's a hole and not a jump. Because if you fill in the open circle and you don't have to pick up your pencil, you just keep on going, it's called a hole, not a jump. But this is a hole, and so it has to stay open. I don't care if it was open red or green. And so thus endeth this. This is discontinuous at x equals 0, and the hole occurs at 0, -2. Now on to the third problem that you're going to have to do. And the third problem is a combination of a parabola on the left that opens up and an oblique line on the right that opens down. And notice here's the open circle, and up there was the closed circle. Notice they have the same ordered pair. So even though this is closed and this is open, closed wins over open, and this will be a continuous graph. Again, you can put the parabola on the left. You can write 0, -1, -2. You don't need to do it the way I did. But notice the vertex is 0, 1. So I'm coming over here, and I put my vertex at 0, 1. And it's supposed to be closed, so I make a nice closed dot. That's a huge dot. And now I'm going to go left 1, up 1. And I'm going to come back and go left 2, up 4. And I'm going to draw my wobbly parabola. Now, for my oblique line, I know the slope's -3. I'm going right, so I want to go down 3, right 1 from the vertex. So I'm going to go down 3, right 1, down 3 more, right 1 more. And that's supposed to look like a nice straight oblique line. And we can see how it's nice and connected, and I don't have to pick up my pencil, and so it's called continuous. For example 3 for problem 3. Now example 4 is going to be for problem 5, because problem 4 on your worksheet is very much like problem 3 on worksheet 4. So now we're moving in, and I'm going to review square roots. But first, know that the left side is a horizontal ray going left. The right side is your standard square root, and it's going right. So I've got a square root ray right. Oh, just look at all those R's. Isn't that beautiful? Notice these ordered pairs don't match, so we're back to the idea of a jump. So I'm going to start with the horizontal. It's open. I know that's really open up there. It's hard to see. But it's open at 2, 3. So I'm going to find 2, 3, make an open circle, and I'm going to head left. And now I'm going to come back to my square root. And you know the square root just reverses the 0, 1, 2, and 0, 1, 4 from your parabola. And since the x is positive, these are positive. Since the outside's positive, these are positive. And so from my vertex of 2, 0, which is closed, so I put in my 2, 0, I'm going to go right 1, up 1. And then I'm going to go right 4, up 2. 1, 2, 3, 4. And so I have my combination of my horizontal ray and my, actually, entire square root. Although we call it a ray, I actually had it start at its endpoint. So it looks like the whole thing, but you can see there is a jump. Now, for the very last one, I'm not making you look at the ceiling this time. I'm letting you just see black. We're going to do 2 square roots, a square root ray left and a square root ray right. And actually what I'm doing are the complete square roots. I have both of their endpoints being at 1, 0. So open and closed wins out, and it's going to be continuous. When I go to do the top one, the green one, I'll notice that my x coefficient is negative, so I need negatives. But my y outside is positive, so these numbers will be positive. And I'm going to plot my vertex endpoint of 1, 0. And it's wrong color. It's currently open. So that's an open circle. And I'm going to go left 1, up 1. And I'm going to go left 4, up 2. 1, 2, 3, 4. And I'm going to draw my square root. Now for the next one, notice the x coefficient's positive, so I'm heading right. So these numbers, the right numbers are all positive. The outside has a negative, so I'm heading down. So the y guys all have a negative. We're starting at the same vertex. It's closed. And now I want to go right 1, down 1. And I want to go right 4, down 2. And I want to draw my square root. And it's really cute. You see how it's nice and it's connected. It's beautiful, and so it's continuous. And so thus endeth worksheet Piecewise 5.